Simplifying a radical expression. So this is a square root. What we need to do is take this 48 and factor it, or if we know a perfect square inside of it, we can use that as well. So first I'll use the factoring method. Every time we have a pair, we can pull one of those out, and then anything remaining has to stay inside the radical. So we have two 2's that we can pull out. We'll multiply those together. And we have v to the 8th. So what we're going to do with this exponent is we divide it by 2. That gives us v to the 4th. There are no remainders on the variables. We have a 3 left inside. So this is 4v to the 4th times the square root of 3. If you know the perfect square inside 48, you can then take the square root of that perfect square, still divide this exponent by 2, and 3 remains. We have 75x to the 8th. Okay. I know that 75 is 3 times 25, so I can use that fact. 25 is a perfect square, so I can bring out the 5. I take this 8 and I divide it by 2. So that's x to the 4th, and there's a 3 that remains behind. If I do not know that, I know that 75 does divide by 5, and I get 5 times 15. Hold on, no. Sorry, that's not correct. I lied, it was correct. So I have 5 times 15, and 15 is 5 times 3. I have a pair of 5's. Again, I'm going to divide this by 2. And so I can pull out that 5, I have x to the 4th, and the 3 remains. Last problem, 54. I know is 6 times 9, and 9 is a perfect square. I'll divide this exponent by 2. So I can pull out the 3 for the square root of 9, u to the 3rd times root 6. If I did not know that 54 was 6 times 9, I can factor it, giving me a pair of 3's, which I can pull out, divide my exponent by 2, and then I have a 2 and a 3 that are left behind, and those get multiplied back together.